Hi, I'm Raibel Suarez. I come from Universidad Austral de Chile. Diabetic nephropathy is one of the most important complications of the diabetes. In the last year, there are many investigations about the increasing of extracellular levels of adenosine in the kidney. It can be because there are an increased activity of ectonucleotidases, or there are a diminishing activity of the equilibrative nucleotide transporter. In this research, we will evaluate the deregulation of the equilibrative nucleoside transporter 2. This transporter can regulate the homeostasis between the extracellular and intracellular adenosine. For this, our aim was to study the mechanisms associated with the deregulation of the equilibrative nucleoside transporter 2 activity and loss of adenosine homeostasis in the diabetic kidney. Well, first, we use glomeruli from healthy rats and podocytes, human podocytes, and we incubated with cytocalysin D, tautomycin, and ELY294002, that this is an inhibitor of PI3K, and the glomeruli were incubated with insulin. The cells were incubated with insulin too. And we can see that the transport of adenosine mediated by this transporter is dependent of insulin, and it is reverted by cytocalysin D or LY2942. And these situations were the same in glomeruli and in the cells. And when the cells were incubated with tautomycin, tautomycin is an inhibitor of the protein phosphatase 1, and the transport were almost abolished. However, this effect was reverted by insulin, suggesting that there are two independent pathways. Right. Then we evaluate the transport in diabetics and healthy glomeruli from rats. These rats were injected with streptozotocin, just 1 dose of streptozotocin, and the glomeruli were sleeved from the kidney. And when the animals have just 1 month from diabetes, the insulin response were almost the same with the healthy animals. However, when the animals have 8 diabetic weeks, there are not response from the insulin, suggesting that there are many relationships between. There are a strong link between the diabetes and the adenosine homeostasis deregulation. For another hand, we evaluated the activation of the PI3K signaling pathway through the evaluation of the phosphorylation of AKT in the setting 473. And we can see when the cells were incubated, the glomeruli were incubated with insulin, there are increases of phosphorylation of AKT. However, when the animals were diabetic of 1 month or 1 month on 2 months, there are not any response from the insulin in the phosphorylation of AKT. The figure 1, 2, and 3 suggesting that there are any relationship between these mechanisms. Okay. Then finally, we evaluated the levels of the equilibrative nucleoside transporter in healthy patients and healthy animals, or in diabetic animals, or in diabetic nephropathy patients. And we can see that in the figure 4, for example, we can see that there are a change in the distribution pattern from the transporter. For example, in the control, the equilibrative nucleoside is concentrated in the basolateral membrane. However, in the animals with diabetes, the pattern is principally intracellular and specifically nuclear. The in the like in the patients, there are the same results. Well, when the arrows, we can see that the distribution, the change in the pattern distribution, suggesting that it is the mechanism that it could be related with the deregulation of the adenosine. It's important to indicate that there are no change in the equilibrative nucleoside transporter concentration. There are any change between diabetes or control. The concentration, the protein levels are the same. And this is an important because everything suggests that the difference is in the pattern distribution. For this, we will evaluate other mechanisms to understand well what is happening. This work is supported by the Fondesit Chile and CONICET, my doctoral fellowship, and the Universidad Austral de Chile.